Hi guys, today I want to do a little video about a particular device called the 431, yeah, TL431, KIA431 you can see here, and these look like transistors, yeah, look just like transistors, but they're not. They're what's called a programmable Zener Diode, yeah, and you find these in most power supplies, switch mode power supplies, yeah. So whether you're talking like this sort of thing, or whether you're talking of an ATX power supply, yeah, it's very likely it will contain one of these devices. And sometimes they go wrong. And when they go wrong, you can get a variety of symptoms, from the power supply giving the wrong voltage or being unstable. Or unstable under load, so you draw more current, the voltage changes. You can have situations where the power supply won't power up, and there's a variety of ways that this can cause the power supplies to misbehave. So on one of the other videos, somebody asked me, he got a power supply, he's one of my subscribers, and he's got an ATX power supply, and it's got one of these he thinks, but his is marked W431, and he asked me, is that the same as a TL431? And I had a quick look on the internet. I went and googled for like TL431, W431, just that, yeah, and I found a number of hits that specifically seem to suggest they are the same thing, but I couldn't find a specific data sheet. So what I'd say is that, is it the same thing? Yeah, it probably is the same thing. I have these KIA431s, they're still the same thing, yeah? They're just different manufacturers, and when we look on the internet, we'll see that there's lots and lots of different manufacturers for these, who will probably have different letters in front of them, but they'll all be 431, yeah? The other way to tell if it's a 431 is probably where it is in the location of the circuit. So if you look at this ATX power supply, this is the one from one of the previous videos. It's waiting for a replacement chip here, yeah? But in this one, if you look, this is the opto isolator here, yeah? The little black thing with 4 legs on, yeah? And the thing I've just moved, that is the 431. I'm not sure I can get a focus on it. This one's a TL431. So just get some focus and you might see it. Okay, I've got the focus. You can see that is actually a TL431A. You'll also find just 431 and 431B. If you're wondering, the difference is actually the tolerance. So a TL431 is accurate as a voltage reference to within 2%, yeah? A 431A is accurate within 1%, and the 431B is accurate within 0.5%. So that's what the A actually donates, and B if you see them, yeah? So in this case, anyway, back to the point, this 431 is next to the opto isolator, yeah? If you have a power supply and you have something you suspect is a 431, this W431, and it's also very closely positioned or connected to the opto isolator, then I would say that is enough evidence to say it is a 431, yeah? TL, KIA, W, whatever. So because we see these so often, it's important that we know how to test them, yeah? But first I'll just explain what the thing actually does. Obviously, if you want to test it, you need to know what it does first, yeah? And then we can see if it's doing what it should do. So I'll just get a piece of paper and a pen. So as I mentioned, the TL431 is a programmable Zener diode, yeah? But in case you're not familiar, let's look at what a Zener diode is first, okay? So a Zener diode, this is the symbol, yeah? Anode, cathode, yeah? And it's connected in a circuit in the reverse direction. So normally a diode, a normal rectifier or a diode used as a diode, will conduct in the direction of the arrow, yeah? From positive. So if positive was on this end, it would conduct, yeah? But in the case of the Zener diode, it's actually connected backwards, yeah? Plus minus. And this effectively is our output voltage, yeah? So what the Zener diode does, effectively, because it's reverse biased, you know, so the positive isn't flowing in the direction of the arrow, yeah, it's reverse biased. Effectively, it doesn't conduct, yeah, and it continues to not conduct and do anything until the voltage across it reaches what's called the Zener voltage. So it's designed at a certain voltage to break down. And Zener diodes come in roughly from about 2 volts to about 150 volts, yeah. So when you get a Zener diode, it will have a specified voltage, yeah. So let's say this one we have here is a 9 volt Zener, yeah. It's a 9 volt Zener. So what happens is, if we increase the input voltage here, current flows through this resistor, yeah. And the output voltage, because this effectively is not conductive, it's doing nothing, the output voltage equals the input voltage. Yeah? Let's pass like a 1k resistor in here. So the output voltage will match the input voltage all the way from 0 volts, yeah, up to 9 volts, yeah? The output voltage here will be the same as the input voltage, yeah? So the output voltage will increase, yeah? When we reach 9 volts, when we take this to 10, 11, 12, yeah, this starts to conduct. So at 9 volts this starts to conduct, and it maintains across the Zener diode 9 volts. So your output voltage will go like this. Yeah? Although the input voltage is still going up, yeah, the output voltage stops at 9 volts, yeah, and the Zener diode maintains that voltage regardless of fluctuations of the input voltage. That's what a Zener diode does. So these programmable Zeners are based on that, but by programmable means they don't come in a fixed value, 9 volts, 10 volts, 12 volts. We can set them to be whatever value we want, basically, from 2.5 up to about 40 volts, I think, is the maximum, so somewhere in that region. So the way the programmable Zener works like this. Again, we have the resistor, yeah, and this is the symbol. So in here it actually is drawn like that, because you can draw a Zener like that as well. Yeah, this is drawn like that. Yeah, anode, cathode, yeah. Reference. Okay. This is your out, same as before. This is your plus volts. This is your 0 volts or your minus, yeah? We can call this 0 volts. Yeah. So by setting the voltage on this pin, we can actually program it to give whatever voltage you want coming out, yeah? And the way that's done is by using 2 resistors like so, yeah? And by choosing the value of resistors, we can set that output to be whatever. So this turns on at whatever voltage we set. We can also do things like this, put a variable resistor here. So by altering the voltage here, we can alter the voltage out, yeah? But the way the thing is designed, it has, if we don't have this resistor, this reference voltage will be 2.5 volts. It generates it, yeah? 2.5 volts, regardless of the value of that resistor. It's only when you put the network in that you can program it. Let me show you the data sheet and you'll understand what I mean. Okay, so this is the data sheet for the TL431, yeah? And it shows you, that's exactly what I've just drawn. I just drew the resistor downwards rather than the crosswards. It makes no difference, it's the same thing, yeah? And basically, it generates its own reference voltage. If it's connected like this, yeah, with no resistor network, it tells you here that the output voltage can be set to any value between voltage ref, which is approximately 2.5 volts, and 36 volts. It wasn't 40, I was close, yeah, with 2 external resistors, yeah. And then it mentions here output impedance, with excellent replacements for Zener diodes, yeah. That's what it is. So that's why they get used so much, yeah. But the interesting thing here is telling us that if you just connect it like this, so ref is connected direct to voltage out, and this is voltage in, this is your resistor. Voltage out will be 2.5 by default, or close, yeah. Also, while we're here, you'll see this is like the package I was looking at, yeah. But they do come in a variety of other packages, surface mount ones. You know, there's a whole different variety. The one you see most commonly is this, yeah. But they do come in a whole variety of different packages. Let's just have a quick look down, because it's such an interesting and useful device. This datasheet, if you're interested in playing around with circuits, this will give you some tests, yeah? Look, this is what I was showing you. So through the resistor, a test circuit for VKA, that's the output voltage, equals Vref. So when it's wired like this, the output voltage will be 2.5, yeah? Then we have where you can put resistors, and it tells you how to calculate the output, yeah? And so on. And we have a lot of further down here, typical applications. It shows you how to build, you know, a shunt regulator, more things. You see loads and loads of examples of how these can actually be used, yeah? So you can see it has a whole wide variety of uses. So if you're interested, come and have a look at this data sheet. It will give you a lot of information. Anyway, that's basically how it works, yeah? And that's really told us, if you think about it, how to test it. And the main important thing of how to test it is, when you have the circuit like this, V out will be 2.5 volts. Regardless of what's coming in, V out will be 2.5. Yeah? So, the way we can test it. Simple. Oh, sorry, that was my Zener Diode. I should have drawn it here. Forget what I'm doing. Okay, so when we have a circuit like this, I'll draw it, yeah? Out, yeah. In, voltage in, yeah. This is our TL or whatever, 431, yeah, 0 volts. And we connect Vref to here, yeah. If we do that, V out will be 2.5 volts, always. Give or take, you know, 2.5, 2.4 to 2.5, there's a bit of tolerance, a couple percentage, you know, for error. But if we do that, it will be 2.5 volts going out. So we can make a very simple tester here. We can connect our power supply to here, yeah? PSU, okay? We can use a 1K resistor. This is where we connect our device we want to test, 3 pins, yeah? And out, we can put here our digital multimeter, yeah? And that is a tester. So, I've built one. And I'm just going to show you this. I'll zoom down and show you what I've built. Okay, so it's a little bit of Vero board or matrix board, yeah? Very simple. So what I've got on here is on the input I have this green and white wire, yeah? And green is ground, 0 volts, yeah? So the white is the positive supply. So the positive supply comes into this resistor, and through the resistor it goes to this pin. Imagine this is going to be one end. This is where we're going to put our device to test, yeah, our TL431. So through the resistor goes to this pin, and through this link it also goes to this pin. So both ends there, yeah, are connected to the resistor, yeah. These two ends, one of them is out, and the other one is ref, yeah. In the middle is 0 volts. It shows you on the data sheet, that's how it is, yeah. So the green is 0 volts, ground, yeah? Right. I have 2 more wires on this, okay. The blue wire is also ground, yeah? And it goes to a little crocodile clip. And the white wire here, if you can see, connects to the other end of this resistor. So this is your 5 volts or whatever coming in, and this here is your V out, yeah? That's the other end of this resistor, okay? Here. Yeah? So you see I built a very simple little device. Now, if I connect this up to my power supply, we'll put 5 volts into it. Then we can see, you know, by connecting across here, the TL431 or KIA431, if it's working or not, yeah? And it doesn't matter which way we connect it round, as long as the middle pin goes to here, the middle. Yeah? We can put it either way round as long as the middle is connected to the middle. Because these are the two ends. This is pin 1, this is pin 3, and this is pin 2. Ref. So that's why we can put it either way around. Okay, so let's not natter about anymore. Let's try it. Let's see what happens. I'll just pause this while I set it up with the bits we need. So I've got this connected to my bench power supply. If I just put the camera over this way, you can see in there, that's my power supply set to 5.3, it's close to 5. And I've got a little switch here, and I have a red and black wire, yeah? So this is my 5 volts coming in, okay? I have my multimeter. Let's get this into the shot so we can see it, yeah? I have my multimeter. So what we need to do is, this is the input, yeah? The green is ground. So this is the negative coming from the 5 volts power supply. If you don't have a bench power supply like that, by the way, you can use something like this. Any sort of 5 volt supply, you know, 6 volt battery would be good enough. It doesn't have to be exactly 5. You can use it, yeah. I don't see any reason why we shouldn't use a 9 volt battery. In fact, I might just try that in a minute, okay? But that's your, as long as you have a voltage input, yeah. Okay. So this is the power coming in, 5 volts, yeah. Put the meter onto voltage range, and then this blue and white, this goes to your meter. So the blue one is ground, negative, yeah, and the white one is the red, is the positive, yeah. And there we have 5 volts. You know, that's what we expect. We got 5 volts, yeah. 5.3. I told you it was set to 5.3 on the power supply. So let's get one of these TL431s. If we connect this across the 3 pads here and hold it on either way round, this should read 2.5. That's the reference voltage, yeah? Huh? That's a good one. And I can turn it the other way round. Yeah? All the way up, doesn't matter. 2.5, yeah? That's a good one. So I have another one. Just make sure I get good contact. Yeah, it's a good one. So this for the guy, I know you're watching, mate. I know you're watching Tech End, yeah, hey mate. For you, if you want to test your W431, test it. See if it is actually faulty. If it reads like this, it's a good one, yeah. And it's definitely a 431. Yeah. Let's do a few more. It's quite therapeutic, isn't it, this? Now we can sit here and test all these things, yeah, just to make sure I get a good connection. Ah, now that one's reading different. That's reading 1.19. That looks like a bad one. So look at the other ones we have. Yeah, that's a good one. That's a good one. So what's this one doing? Huh? Why is this one reading different to all the others? 1.16. So that looks like a bad one. But let's have a look at it under the microscope, yeah? Let's see, first of all, is it a 431? That's the first question, yeah? Is it actually a 431? If it is, it's faulty, yeah? Okay, let me get the microscope camera working, let's have a look. Okay, so here's our faulty one, yeah? Where are you? And it's this is a KIA431, whereas the other ones, that's a KIA431, yeah? These are 431s. What's this one? Oh, this is a TL. Yeah, TL431. Yeah? C. That must be a different tolerance again. So these are 431s, but it's fairly obvious that this one is something different. The 2431. What's this one? Yeah, that's a KIA431. So this one is a similar device, but it's not the same. It certainly ain't compatible. I suspect it is a programmable Zener Diode, but a different voltage one, yeah, the lower voltage one that will go down to about 1.5, yeah, and that's why that's reading lower. I'm pretty sure. I'd have to go to the datasheet to do it. Yeah, let's do it. Let's have a quick look, because I don't know what this actually is. Let's go online and find this KIA2431 to see if we can determine if it's actually any good or not, yeah. See what it is. KIA2431 datasheet. What's it tell us? It's a linear, it's a programmable, it's the same sort of thing, yeah? The same sort of thing. Go on, give me a datasheet, please. Seems to have stopped. Well, try again. If not, I'll have to look somewhere else for it. Let me try, like, let's give it another go. It is a programmable voltage reference, it tells me that. No, I don't seem to be able to find it. Get the datasheet. Let's try another site. KIA431. Is it going to work this time? I'll just pause this while. let me just. Oh no, I've got it now. I've got it. Okay. So if we get a datasheet on this, probably, yeah, it's the same sort of thing, but I reckon it's a different voltage reference. Yeah. 1.24 volt. That is a good one. It's just a different type, so we know that is not compatible. So your W431 tech ends, have a look. Yeah, assuming it isn't faulty, because you haven't told me maybe it's short. You know why it's faulty. Maybe it isn't faulty. Maybe you need to test it. Yeah, let me know. Okay, so last thing I'll show you with this. We don't need the microscope anymore. Let me just zoom out. So this is the ATX power supply, yeah, and I said in here is a 431, yeah. Well, this little tester I've made, we can actually use this in circuit. The three little legs here, if I push them against the pads where this 431 is soldered, I should be able to test it in circuit. So let's see if we can do that. Okay. Zoomed in a little bit, so it's all connected up. So this is our little tester. The 431 is actually here. This is the opto-isolator across the big divide between the hot side and the cold side, yeah, high voltage and low voltage. Let's see if we can connect this onto here, so we get a good connection with it. Yeah, look, there you go, 2.55. So I'm now testing them in circuit as well, yeah, and that worked okay. So we know that's a good one. That's handy. Last thing, let's just try this with a 9 volt input. Obviously then you could basically make one of these using a 9 volt battery, which would be very handy to have a portable little tester. Okay, so that's working. Let's take the voltage up to 9. It's close enough, isn't it? I mean, 9.5, it's close enough. Let's see what happens now. This should do the same. We should get the same reference voltage. 2.48. So yeah, you could build one of these using a 9 volt battery. Would be quite a handy little version of it. Okay guys, I hope that was not too long a video. That's how you test these KIA431s, or determine if the device you've got is actually a KIA4 or TL or whatever 431. I'll see you soon in another video, guys. Cheers now.